Madhumita. I recently completed my bachelor's degree in computer science and engineering. As I have interest in cloud computing, I wanted to build practical knowledge in cloud and DevOps. So I completed AWS and DevOps training in Qtree technologies. During this training period, I gained practical knowledge in AWS services, also in DevOps, and also I learned how to use Terraform and CI/CD pipelines and Docker, etc. Also, I have worked on several hands-on projects like AWS Auto Scaling project, Capstone Terraform modular infrastructure project, and Dockerized motivation codes application. Today, now I am going to explain my AWS Auto Scaling project. The main objective of this project is to automate application deployment and ensure the application can automatically scale based on user traffic. This helps improve application scalability and availability, reduce manual effort. Now let me walk you through my project. First of all, this is my project folder, which is AWS Auto Scaling project. This is the directory, and inside the directory, these are all the files I put my script into readme.md. In readme.md, it is like the face of my project, which contains the structure, how I created this project, and what are all the services I deployed and how I deployed the services. Everything is inside readme.md. Also, it followed by destroy.sh, which is a script to destroy the applications, to destroy the services that I've made in AWS console. Also, it contains output tf, terraform tf, state, user data.sh, and deploy.sh. Coming to deploy.sh, it is used to run my application using shell scripting like that of destroy.sh, which is to destroy. Deploy.sh is to run the application and create the services in AWS console. And main tf, it is the main file of my project, which contains all the infrastructure to create auto scaling group, EC2, load balancer, target group, etc. Also, I have provided a tf terraform tf state.backup. Now let me open my GitHub repository. Here, as I shown before, these are all the folders I've created before. After deployment, the folders are pushed to Git. Now let me show my CI/CD pipelines. Whenever I make changes to the application, I commit the changes and push them to GitLab. This becomes the starting point of my deployment project. Here you can see the latest pipeline executions, which are deploy stage and destroy stage. As I run this project before, you can see two stages are ticked. Only deploy stage will tick if you run the project, and destroy will tick only after you are given it manually, because it is to delete all the resources. The pipeline actually fetches the latest code from GitLab and executes the deployment steps that I have configured. This is one of the major advantages of using CI/CD, because it saves time, reduces manual work, and provides a consistent deployment process. Now, let me move to the AWS management console. First, I'll move to EC2 instance and show you my instance. First, I launched an EC2 instance and I deployed my application. Once everything was working correctly, I created a launch template. This launch template contains configuration required to launch a new EC2 instance, including AMI ID, instance type, security group, and other settings. Using launch template, it ensures that every EC2 instance is created by auto scaling has same configuration. Next, this is my auto scaling group. Auto scaling group continuously monitor application workload and automatically adjust the EC2 instance based on CPU utilization. When traffic increases, auto scaling AWS automatically launches new instance, and when traffic decreases, AWS automatically terminate unnecessary instance. Now look at the application load balancer. This is project ALB, which I created for this project. Load balancer receives requests from user and distribute them evenly across all healthy instances. This improves application performance. Next, go into target groups. Here you can see that instance are healthy or unhealthy. If the instance is healthy, it passes to health checks. If it is unhealthy, then it did not process the health check. To verify that our auto scaling policy was working correctly, I generated CPU load on the EC2 instance manually. As you can see that here, Amazon CloudWatch automatically monitors the CPU utilization. Here now let me click the instances which are created, and in monitoring tab we can see that the CPU utilization graph is increasing when I give CPU stress manually, and after that I stop the stress, it decreases gradually. When the CPU utilization crosses the threshold I mentioned, auto scaling creates a new instance, which is this instance, and after the threshold decreases, it will automatically delete the instance. This confirms that auto scaling policy works successfully. As you see, this graph increases and decreases, and new instance is created. After CloudWatch period, auto scaling group automatically terminate the additional instances. It terminates all the additional instances created whenever the CPU utilization comes to the normal threshold. Now let me explain the advantages of my project. The first advantage is high availability. If one EC2 instance become unavailable, it stops sending traffic to the unhealthy instance. And it waits until auto scaling group creates new instance and a target group perform health checks. After only the instance health check is passed, it distributes the traffic to the new instance. The second advantage is automatic scaling. Infrastructure automatically adjusts scaling. Whenever it increases stress, it automatically creates instance, and whenever it CPU stress decreases, it automatically deletes. The third advantage is cost optimization. During low traffic, unnecessary EC2 instance leads to high cost. So that as it automatically scales, we can avoid cost. Another important advantage is deployment automation. By integrating CI/CD pipeline, application updates become faster, more reliable. So through this project, I gained practical experience with the Git, CI/CD, EC2, launch template, auto scaling groups, etc. More importantly, I understand how these services work together to build scalable, highly available applications. Overall, this project strengthened my understanding of AWS and DevOps. Thank you for Qtree to make me help to gain these knowledges. Thank you for taking time to watch my project demonstration. Thank you.